Hello, I'm in my office today, so I don't have my usual video recording setup that I have at home, so this video is going to be a little different. I hope it sounds okay, and we'll be back to our normal types of videos with the next one. Okay, so, and I actually already tried to make this video and it didn't record. Okay, so we're just going to be walking through this instead of me writing all this down again. So sorry about that if it's not quite as if it's not what you're used to, at least. Okay. So in section 2.2, we're talking about graphs of functions. So when we're talking about a graph, we're talking about being in the XY plane where we have positive X values on the right side, negative X values on the left, positive Y values going up, negative Y values going down. And then what we do is we have ordered pairs, is what we'll call them, X comma Y. So our first number would be our X value, and then our second number would be our Y value. So here I've got a point plotted. This point is the point 1, 2. Okay, because to get there, you go to the right 1 and then up 2. Okay. And another way you could write these, since we're talking about functions, remember Y is just our output for our function, or we could also call it f of X. So you could also call these points X comma f of X. Okay, and so you have a couple of questions on WebAssign that say something like the point 2, 3 is on the graph. So what is f of 2? Well, f of 2 is just 3. Okay, that would f of 2 there would just be another name for the Y value. Okay, so don't let those problems trip you up. They're supposed to be easy. Okay, if you remember that it's X comma Y, then those are not too bad. Okay, so when we talk about the graph of a function, we talk about all of the pairs of inputs and outputs that we can get from a function. Sometimes they're infinitely many, okay, so we don't want to have to figure out all those. But what we can do is we can pick a few and then plot those points, and we get an idea of the shape of the graph. So here I've got an easy little function, f of x equals x minus 1. So what we would do is we're just going to pick some x values. I just did from positive 3 to negative 3, just doing whole numbers. Okay, and then we take those inputs, plug them into our function, and we see what we get for an output. Okay, so here if we plug in 3, then 3 minus 1 would be 2. So that would be our output. If we plug in 2, 2 minus 1 is 1. If we plug in 1, 1 minus 1 is 0, and so on. Okay, so, and if we plot those points, like the point 3, 2, 3, 2 is right here, right to the right, 3 up 2, then we just plot all these points and we can connect the dots, and we see that the graph of this function is going to be a straight line, or what would be a straight line if we actually had graph paper here. With my hand-drawn things, it's a little bit crooked. Okay, but that's a good way to get the idea of the shape of any type of graph. So for any function where you want to know what the graph looks like, you can take some points, and you pick some x values, plug it in to see what you get out for your y value or your f of x, plot those on the graph and connect the dots, and you get an idea of what the graph looks like. Okay, it is useful to have some basic or some common graphs in mind about what the general shape's going to look like. So we've got a few of these I want to show you. If we have f of x equals x squared, okay, generally with x squared you're going to get this U shape that we kind of like a U shape that we call a parabola. Okay, so that's a good one to know. X to the third is also a good one to have in your memory. It'll help out down the road. So if we have x to the third, we have this one that comes in from the bottom and kind of takes a turn and then goes up toward the top. Okay, so we get this kind of shape for x to the third, or x cubed. Okay, another good one to try to get in your memory is the square root of x. Okay, square root of x, we don't have any of the graph on the left side, because if we try to take the square root of a negative number, we don't get real numbers, right? We get complex numbers, and with our graph and our coordinate plane, we're only dealing with real numbers. So we get this kind of shape for the square root of x. And then one more that's useful and it's easy to identify is absolute value of x. So for absolute value, no matter what number you have in there, you take the positive version. So absolute value of -3 is +3. Absolute value of +2, +2. If it's already positive, you leave it positive. Okay, so for absolute value, we get a V shape on our graph, and that's pretty unique and easy to identify as absolute value. Okay, so the next thing we need to think about is if we're given a graph, how can we tell if that graph represents a function or not? We haven't really talked about the definition of a function in detail yet, but the idea is that we have some rule that takes each input and sends it to exactly one output. Okay, that is one definition of a function. And graphically, that gives us this thing we call a vertical line test. Okay, so the vertical line test says if we can come up with any vertical line that touches our graph more than once, then the graph is not a function. Okay, so for a function, no matter what vertical line we draw, it's only going to touch our graph at most once. And that's another way of saying it. So these others we've looked at, you saw my doodles on there. Okay, here, no matter where, for absolute value of x, no matter where we draw a vertical line, the most times we can get it to touch our graph is once. Right, so it is a function. Same thing with square root of x. No matter where we draw a vertical line, the most times we can get it to cross our graph is 1. So it is a function. And the same is true for the others that we've looked at. Okay. So what would a graph look like that fails the vertical line test? It is not a function. Okay, well, how about this one? So here there are several places we could draw in vertical lines that touch our graph more than once. I drew in one that touches it 3 times. Okay. So if you can just draw in one line that touches the graph more than once, that is enough to say that graph is not a function. Okay, so this one is not a function. It touches it more than once. In fact, it touches the graph 3 times. Okay, so not a function. Okay. And then the last little topic, you don't need it much in this section, but the last little topic that is helpful is talking about the domain and range of a function based on its graph. So here I've got a little graph drawn in. And the way we figure out domain and range, remember what domain and range are. Domain is the set of the inputs, so we want to know what range of values our inputs cover. Okay? Or in other words, what x values is our graph between. Okay? And then for the range are output values. So for that, we want to know what y values does our graph cover. Okay? So here for our domain, the farthest to the left, or the smallest x value that we use, is -2. So that's where our domain starts. And we're including -2, so we have a square bracket. Okay? And then our graph goes off to the right, and it ends at an x value of +3. So that is where our domain ends. And since we are using negative, and we are using +3, we have a bracket. Okay, we have a filled in circle at 3, so we have a bracket. If it had an open circle, you would use a parenthesis. Okay, and then what about our range? Yeah, I've got it drawn on there, and I didn't draw this one very well, but if you look, you say, okay, so how far down the y-axis does our graph go? Well, here this goes down to -2. So our range starts at -2. And then how far up our y-axis does our graph go? So it goes up to a maximum of +2. So our range ends at +2. Okay? So that's one way of thinking about getting the domain and range from looking at the graph of a function. Okay? All right, I hope that helps. I will be back to our normal video making schedule now that Tester graded, and I will be back to my home setup where probably the audio is a little better. I hope this is okay. And if you have any questions, let me know.